In this presentation, we'll get practice designing a class interface and then implementing a few member functions in the class. One question on the final exam will have a similar format, where you'll be given a set of requirements and you'll have to design the class interface and implement a few functions. So because you'll be doing a question very similar to this next Saturday, it's highly recommended that you attempt the questions before checking the solutions in this presentation. The class that you'll need to design the interface for is called contacts. It'll be used to track a bunch of objects of type contact, which contains two pointers to characters, which will be the contact name and contact phone number. In the requirements, you're also told to use the class LLContact, which is a linked list that's already implemented for storing those contact objects. So if you haven't already done so, please take this time to try to do questions 1 and 2. Let's begin by going over the solution to the class interface question. First of all, I want to mention that there's always going to be variations, and what I've done is only one possible solution, but what you've done shouldn't be drastically different from what I've done. For example, you shouldn't have a bunch of extra member functions that aren't part of the requirements. And also you shouldn't have extra member variables unless they're necessary to meet those requirements. Let's begin by looking at the data members for the class. So following proper object-oriented class design, the data members should be private. 2 of the data members are directly given in the requirements. One says that we have to use LLContact to manage the list, and the other one says that we should have a title for the class. I've used a character pointer for the title, but you could have also used a C++ string. And that's because the question didn't specify to use one or the other. So either would be okay. And the last member variable is the number of contacts. And this one isn't explicitly stated, but it is implied through the requirement that says the user should be able to get the number of contacts they have quickly. Also, you're told that the linked list itself doesn't keep track of the number of contacts, so that means that you have to manage the number of contacts yourself inside of the contacts class. Now let's look at all the member functions in the contacts class. There was no need for a private member function, so everything is under the public section of the class. So I'll start from the top. In bullet number 2, it says that you should be able to create an empty contacts. So that implies the default constructor, and you should be able to create a copy of an existing contacts, so that's a copy constructor. And the last way that's mentioned is you should be able to create contacts from a given file name. So that gives us the third constructor, which takes a pointer to a character for file name. And because we're asked to make the class safe to use, and we're supposed to use const wherever possible, the arguments for both constructors are const, because inside the constructor we don't want to be changing the file name or the given contact in the copy constructor. Now the next 2 functions are implied through good design of object-oriented classes. There's no stated requirement that you should have an assignment operator or a destructor, but because you defined the copy constructor, the law of Big 3 tells us that we should implement the assignment operator and the destructor as well. The next bullet in the requirements says that users should be able to add a given contact or remove a contact given a certain name. And again, because we're designing a safe to use class, we make those arguments const so that we don't change them inside of the function. You could have used a bool for a return value, but it wasn't clearly specified, so a void or no return value is also acceptable. The next bullet says that users should be able to update a given contact's phone number. So for this, there was 2 choices for the argument to update. What I've done is given a reference to a contact, or you could have also given 2 strings, one for name and one for phone number. Either would be acceptable. In each case, you should be using const arguments to ensure that you don't change the given arguments inside the function. One of the bullets also tells us that we should be able to import or export to and from a file of a given name. So because it says of a given name, we have to accept an argument to a file name. and that could be a character pointer like I've done, or it could have also been a C++ string because it wasn't specified how to represent that file name. And lastly, we have the access member functions. The first one is getNumContacts, which returns an int, and the entire function is const because get functions shouldn't be changing member variables. Recall that because proper object-oriented design has information hiding, the data member itself is in the private section, so we need a get function for accessing it. And similarly for the title, we have a get and a set function. For the get function, because we're returning a pointer, I'm returning a const char pointer, which will enforce that nobody can change the title from outside of the class. If I return just a char pointer, it would be possible to change the title from outside the class. We didn't deal much with const return values in this course, so something like that, if you forgot the const, wouldn't make a difference on your exam mark. But there is the entire class interface, and you can go back and check that all the requirements are met by these functions. And also we had some extra ones that came in because we're following good practice for object-oriented design, and that was the assignment operator and the destructor, because the law of big three tells us if we implement one of the copy constructor, assignment operator, or destructor, we should implement the other two. Now if you haven't already began implementing the add, remove, update, and copy constructor, please take a moment to do so now. For the add function, we're given a contact, and we need to insert it into the list. There's really only one trick here, and that's the list won't accept duplicates. So if we try to add a contact with the same name as an existing contact, the list won't add a new node into it. And in the case where we add a duplicate, the return value for insert would be false. But if we do insert a new contact into the list, it'll return true, and we should increment numContacts. Remember that we have to manage numContacts inside of the class. Remove is similar. If we're given a name that's not in the list, remove will return false. But if the name is in the list, that node will be removed, and we should decrement numContacts. For the update function, there's a couple different strategies that would work here. The one that I've chosen is to use the two functions that we just made, remove and add, and note that the requirements of the update function are met if we remove the node and then add a new node. This is a somewhat simpler implementation than using the linked list find method, which will return a pointer to the contact if it is in the list, otherwise it will return null. But if it is in the list, you'll need to allocate new memory for the new phone number, and then assign the pointer inside of the list to point to the new memory, and then delete the old memory. I think you'd agree that calling remove and then add is somewhat simpler. So when you're asked to implement member functions, it's good to note what the other member functions are doing in case you can use them to make your implementation simpler. The last function that we're asked to implement is the one that creates contacts from a given file name. Again, there's two strategies for this. We could implement the functionality that opens a file, reads contacts, and inserts them into a list. Or we can notice that we have an import function inside the class already, which will do the same thing. If we use that import function, all we need to do is set the initial values for the contacts so that numContacts starts at 0, and the title will be an empty string, or just a \0. Once the member variables are set to their default values, we can simply call the import contacts function, which will add all the contacts to the list. In this presentation, we've gone through the solution to an exam-style question dealing with class interfaces and class implementation. When you design a class, you should follow information hiding, which usually means that all the member variables will be private, and if you should have access to member variables from outside of the class, you'll need to do it using get and set methods. And another thing, if you're asked to make the class safe to use, you should use const where appropriate. That'll mean that arguments that shouldn't be changed should be passed in as const. And if a member function shouldn't change any member variables, remember to make the function const. And one more thing to remember, and that's the requirements will specify several functions to be implemented. If the functionality of one member function can be achieved by using other member functions, then it's safe to use those. And it'll also make the implementation easier. But for the exam, be careful with this, because if you create unnecessary member functions to avoid writing implementation, I won't be able to give you very many marks for something like the example that's given, where you're asked to write the export function for the contacts, and the implementation simply calls another function called export to file. If you compare that to the constructor that took a file name and called the import function, that was valid because the import function had to be implemented and was given in the requirements. If you want more practice implementing member functions, you can try to implement all of the contacts member functions. And if you want more practice with LinkThis, you can implement the member functions for LLContact. I've posted all the implementation details on Blackboard in the workbook and slides section under Code Developed for Spring 2003. And the file is called contacts.cpp.